Hello everyone, today I have a really fun problem for you, and this is a problem from the INMO, the INMO, International Mathematics Olympiad, and we're gonna learn a little bit of Vieta oscillations and what cubic residues are. And this is a really cool problem because it does not involve a lot of complex stuff. Like you don't need to know some really complicated theorems or really complicated problem solving ideas. It's just simple Vieta oscillations and a little bit of congruence modulo. So let's start and let's see how we're gonna solve this. This is a problem number 2 from the International Mathematics Olympiad conducted in 2017. And in this video, we're gonna see a review of Vieta oscillations and what cubic residues are. We're gonna see how taking the mod n, how reducing equations mod n helps us to solve problems. We're gonna see some book suggestions for number theory, and at the very end, we have similar but challenging problem. So let's get started.
This video is sponsored by Cheenta.com. Since 2010, Cheenta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students. Cheenta programs are designed for students who are passionate about mathematics, and they are personalized with one-on-one training, individual evaluation, and remedial sessions.
This is a problem that is given to us. Suppose n greater than 0 is an integer and all roots of the given equations are integers. So find all the possible values of alpha. So first of all, we need to know what Vieta's relations are, right? So for example, we have a polynomial p of x is equal to a0 plus a1x plus a2x squared till an x is power n, right? If let's say this is the polynomial, so this Vieta's relations tell us. Well, Vieta's relations tell us that the sum of roots taken one at a time, so sigma alpha will be minus of an minus 1 divided by an. If we take the sum of roots 2 at a time, these are just notations for sum of roots 2 at a time, that will be an minus 2 divided by an. If we take sum of roots 3 at a time, alpha beta gamma, that will be negative an minus 3 divided by an, right? And n minus is also in subscript. And so this is how the Vieta oscillations go. So sigma alpha is sum of roots taken one at a time. So let me just illustrate what this is via an example. So for example, if we have a cubic polynomial, ax cubed plus bx squared plus cx plus d, and in over here, what will be sigma alpha? Sigma alpha will be sum of roots taken one at a time. Now the cubic polynomial obviously has 3 roots, alpha plus beta plus gamma, and that will be equal to minus b by a, right? If we have sigma alpha beta, that will be alpha beta plus beta gamma plus gamma alpha, that will be equal to c by a, and we have sum of 3 roots taken at a time, that is alpha beta gamma in this case, and that will be equal to minus d over a. So that's how this basically works. And over here they have given us this equation x cubed plus alpha x, and then we have plus 4 minus, I believe this is 2 times 2016 raised to power n is equal to 0, right? Perfect. Okay, over here if we just apply Vieta oscillations, we will get certain things. First of all, you can notice that the coefficient of x squared is 0, right? So alpha plus beta plus gamma, if there are the 3 roots, let me not use this notation. Let me use a, b, and c for the roots. Let the roots be a comma b comma c. So then a plus b plus c is equal to 0, right? Just for simplicity of writing. And then we also know that ab plus bc plus ca is minus alpha, which we need to find. So it's will be positive alpha. Okay. So ab plus bc plus ca will be alpha, and then the product of roots abc is 2 times 2016 is for n minus 4. Okay. Now how can we work with this? Now when a plus b plus c is equal to 0, a cube plus b cube plus c cube is equal to 3abc, and this is a pretty known result in elementary algebra. And so then basically I can write a cube plus b cube plus c cube as 3 times 2 times 2016 raised to the power n minus 4. Okay, now that we've gotten up till here, I can just take mod 7 on both sides. So a cube plus b cube plus c cube mod 7 will be equal to 3 times 2 times 2016 raised to the power n minus 4 mod 7. Actually, the interesting observation is that 2016 is 0 mod 7, right? So 2016 is actually divisible by 7. So 2016 raised power n will also be 0 mod 7, right? So a cube plus b cube plus c cube will be basically negative 12 mod 7. And instead of having this negative remainder, I can just write this as 2 mod 7, right? This will be 2 mod 7. Now we can notice one thing. Now, if you remember the result that a cubic residue, like sum of 3 cubes, can never be 2 mod 7, that's okay if you remember. But even if you don't remember, we can actually just take some cases. So for example, I'm gonna be seeing some values of a, and then I'm gonna be comparing them with a cube mod 7, right? So if you have a is equal to 1, a cube mod 7 is 1. If you have a is equal to 2, 2 cube mod 7 is also 1. If you have 3, you have 3 cube mod 7, which is minus 1. If you have 4, we have 4 cube mod 7, which is 1, and so on and so forth. So my point is that a cube can either be 1 or minus 1 mod 7. Minus 1 is obviously 6 mod 7. So a cube can be either 1 or 6 mod 7. So really, a cube plus b cube plus c cube can only ever be, it can only take certain values, right? So what can it take? It can be 1 plus 1 minus 1, so it can be 2 mod 7. So it can be 1 mod 7. It can be minus 1 mod 7. It can be 3 mod 7, and it can be minus 3 mod 7. Why? Because, you have a cube, b cube, c cube, right? So you have sum of 3 cubes, and a cube we've seen is 1 or minus 1, right? So these 3 can either be 1, 1, 1, minus 1, minus 1, minus 1. 2 can be 1 and third can be minus 1, or 2 can be minus 1 and third can be 1. And really the sum of these 4 would only give us 1, minus 1, 3, and minus 3 mod 7. And you can really check that out. So my point is that a cube plus b cube plus c cube can never be 2 mod 7, right? So therefore, a cube plus b cube plus c cube can never be 2 mod 7. But we actually had figured out that a cube plus b cube plus c cube is 2 mod 7. And because it can never be 2 mod 7, we can really say that small n is equal to 0. And once that we've established this, it actually becomes pretty simple. Because we had a plus b plus c is equal to 0 from Vieta's relations. We had abc is equal to 2 times 2016 raised to power n minus 4. So when n is 0, abc becomes minus 2. So we really only need to solve 2 equations. One of them is abc is equal to minus 2, and the other one is a plus b plus c is equal to 0. So now we kind of need to solve these 2 equations, and you will really easily see that the solutions to this are a comma b comma c is equal to 1 comma 1 comma minus 2 and its permutations and its cyclic permutations. Okay. So 1 comma 1 comma 2 and all of its permutations. How many permutations it will have? It will have 3 factorial divided by 2 permutations. So that will be 3 permutations. So 1 comma 1 comma minus 2 and all of its permutations will be the solutions of these 2 equations. And it can really be easy to see because abc is equal to minus 2, right? The product of 3 integers is minus 2. So it can only take certain values, and it is 1 comma 1 comma minus 2 in cyclic permutations, just by observation. Okay, so and now we had to find out the value of alpha. Now what was alpha? By Vieta's relations, it was ab plus bc plus ac. So I can basically write this as abc. I'm taking abc common, so I get 1 by a plus 1 by b plus 1 by c. abc was minus 2, so minus 2 times 1 by a plus 1 by b plus 1 by c. Now no matter what these cyclic permutations are, the sum of 1 by 1 number plus 1 by second number plus 1 by third number is always going to be constant, right? So it's always going to be same no matter what the individual values of a, b, and c are. So this will just be 1 by 1 plus 1 by 1 minus 1 by 2. So alpha will be negative 2 times 2 minus 1 by 2. And if you just compute this, alpha will be negative 2 times 3 by 2. Therefore, alpha is equal to negative 3. And that's actually the correct answer. That's what we really saw. We only used elementary number theory and a little bit of Vieta's relation to solve this problem. Nothing really exotic. So this is actually a solvable problem. This is problem number 2 in that year. And yeah, I really hope you learned a lot from it. Cool. So coming on to certain book suggestions for number theory, we have Excursion Mathematics, we have The Challenges and Thrills of Pre-College Mathematics, we have Elementary Number Theory by David Burton, and we have The Elementary Theory Numbers by Sierpinski. And at the end, we have a similar but challenging problem, And yeah, I want you to find all triplets A, B, and C such that the number n is a power of 2016, right? So it's kind of like a similar concept. You again gonna have to make certain cases and reduce it to the mod of some number, right? Reducing equations mod n, very important concept, right? So n is basically 2016 raised to power k for some integer k, for some natural number k, right? And you need to find out the value of all triplets A, B, and C that satisfy this given equation. So as usual, if you've made any progress on it or if you've solved it, please let me know in the comment section below, and I'll be sure to respond to it. Until then, that's it from me. Bye bye.
The reason Cheenta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Cheenta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit cheenta.com.